All right, this is the section 1, 2 PowerPoint voiceover functions. So let me start the PowerPoint. Function that corresponds between a first set of elements called the domain and a second set that's called the range. The y values, domain set of x values, range set of y values. And in a function, special is that each member of the domain, each x value corresponds to exactly one member in the range. One x goes to one y value. It's important to note that not every corresponds between two sets is indeed a function. Here we've got an example of a function pay-as-you-go exercise program. You pay $20 membership fee and you pay $7.50 for every class you attend. So if a person attended 7 classes, it'd be 7 times 750 plus $20. You'd owe 72.50. One class, you pay 27.50. Two classes, 35. Four classes, 50, and so forth. Notice this corresponds as a function for every x value. For every number of hours you attend, you only have one price. One gets assigned to 27.50. All right, and two gets assigned to. It's an example of a function. Here we've got number of representatives in each state. Notice that each state only has one number of representatives. Alaska has seven. Arizona's got eight. Now here's a case where Alaska has seven and Colorado has seven. In a function, all right, many can go to one. All right, Alaska and I guess Colorado can go to seven, but Alaska can't go to seven and go to, let's say, 25 or 53. Many can go to one, but one cannot go to many. All right, so this is indeed a function. All right, your domain would be the set of all first elements. In this case here, Alaska, Arizona, California, the states. And your range, all right, your would be 7, 8, 53, 25, and so forth, set of second values. Determining whether relations represent a function. Wendy's hamburger gets assigned 19. Fats, calories. Here again, McDonald's gets assigned 23. McDonald's doesn't go to 23 and to 29. For every member of the domain, you get assigned to exactly one value. Now, it's okay that the Burger King gets assigned to 23 and the McDonald's. Many can go to one, but one can't go to many. So your domain is 410 set of all first values of calories, 410, 430, and so forth. And your range is a set of, in this case, calories from fat, 19, 23, and so forth. No, it's okay for more than one element of the domain to correspond to the same element. Many can go to one, but one can't go to many. Here you do not have a function, reason being that this ring with 0.86 carats gets assigned to $3,329 and also gets assigned to 3,097. You can't have an element in the domain going to multiple elements in a range, not a function. All right. Each element in the domain does not correspond to exactly one in the range. 0.86 has two prices, not a function. A relation is a correspondence between the first set of the domain, here again we know this, and the second set called the range, such that each member of the domain corresponds to at least one element. Determine whether the following relation is a function. 9 gets assigned to -5, and then 9 gets assigned to 5. Can't have that. You can't have an element in the domain getting assigned to multiple elements in the range. All right. 9 gets assigned to two values. No, not a function. Notice 9 has the ordered pairs 9, -5, and 9, 5 have the same first element. First, yeah, and then a different second coordinate. Can't have that. -2 gets assigned to 5, 5 goes to 7, 0 goes to 1, 4 goes to -2. What I know is right off the top is that there's no element in the domain repeated more than once. So how can it get assigned to more than one value when you don't have it repeated? All right, here it is. Here's the assignment. -2 goes to 5 and so forth. Yes, you've got a function here. No two ordered pairs have the same first coordinate and different second coordinates. Your domain is a set of all your first values, and your range is a set of all your second values. What have you got here? -5 goes to 3, gets assigned. 0 gets assigned to 3. 6 gets assigned to 3. That's fine. Many can go to 1. That's not a big issue. All right. All the elements in the domain are getting assigned to the same element in the range. This is a function. No two ordered pairs have the same first coordinate and different. Many can go to one, one cannot go to many. Your domain is a set of -5, 0, and 6, and your range just has one element in it. And that element is, in this case, the number 3. The inputs, members of the domain, are values of x substituted into the equation. The outputs are members of the range. This is read as f of x, all right? It's function notation. Sometimes we call it f at x, but most times it's read f of x. Not f times x, f of x. Given a function defined as f of x equal 2x squared minus x plus 3, find each of the following. F of 0. So what I'm going to do here is in place of 0, all right, I want the value of the function when your x value takes on a value of 0. So in place of x in the function, substituting in 0, you see it in red and doing the algebra. The f of 0 works out to be positive 3. F of -7 in place of x in two spots that I see it. You're going to substitute in -7 here. You see it in red and doing the algebra. -7 squared is 49, doubling 49. A minus times a minus is a positive. 49 plus 10. 49 times 2, plus 7 and 3 more, 108. F of 5a. So in place of x, we're substituting the monomial 5a. All right, so you see it substituting in place of x. You see it in red. In place of x, you see 5a in red. And doing the algebra, doubling up, squaring first, and then doubling and subtracting 5a plus 3. That's all you can do with this one. There's no like terms here, so you've simplified it as much as you possibly can. Sometimes we have to substitute in place of x a binomial. All right, in this case, we're finding f of a minus 4. Now, just give you a heads up here. A minus 4 squared. It's not a simple matter of just squaring the a and squaring the -4. A minus 4 quantity squared means a minus 4 times itself. You have to FOIL this out. And when you FOIL a minus 4, you get a squared minus 8a for a middle term plus 16. You're going to double that, subtract a, and do the algebra involved here. And when you simplify this, you come up with the trinomial 2a squared minus 17a plus 39. Just a heads up, a minus 4 squared is not simply squaring the first and second term. You've got to FOIL this. You're multiplying a minus 4 times itself. We can graph functions the same way we graph equations. We find ordered pairs x and y, or f and f of x. Notice f of x and y are synonymous. An f of x is nothing more than a y value. You could use a table of values. Your calculator actually can do this for you, and I'll talk about that in a separate video. You get a square term, it's a parabola, second degree equation. All right, f of, let's see, when x is -3, your f of x is 4. When x is -2, your y value is -1, and so forth. When x is 3, you see the accompanying y value here is 4. F of 3 would be 4. And here I'm just simply graphing this, and we'll do a lot of several videos on using your calculator to graph. Once again, it's a third degree equation. That's what it looks like. And I was careful here to set my window to -5 to +5 on the x-axis and +5 to -5 on the y-axis. And we'll do a lot of these graphs. F of x is equal to the square root of x plus 4. Here you see it plotted into my calculator. And this is what the graph looks like. And f of -3. F of -3. When x is -3, your y value is +3. All right, when x is -3, if I follow the graph up here, f of -3 is +3. F of 1, apologize that this is looking a little overlapping. F of 1, when x is 1, your function returns -5. All right, you go over 1, down 5. 1 squared is 1, 1 minus 6, there's your f of 1, -5. Vertical line test. An easy way to tell whether the graph is indeed a function is to drop a vertical line through the graph. If it touches the graph in more than one spot, it's telling you that for that x value, there's multiple y values. You haven't got a function. This guy passes the vertical line test. This guy flunks it miserably, hits it in 3 spots. In other words, for that x value, let's say it's -1, you got a y value there, another y value there, you got multiple y values, not a function. This obviously flunks the vertical line test. It's the graph in two spots, which tells me for that x value, there's a y value there and a y value there, a positive and a negative y value. No, not a function. Circles flunk the vertical line test. This passes it. And the second one passes it because this is a closed circle and that's an open. So if I drop the vertical line, it would not hit that because it's an open circle. The domain is understood to be the set of all your inputs. All right. Now, a function sometimes described as a function machine. You input an x value, the function deals with it, all right, squares it, adds, subtracts, whatever, and it outputs a y value. And y and f of x are once again similar. They're very similar. They're exactly the same. Those two ways of expressing the same thing. And you wonder why I've got a picture of a microwave. Well, with a function, you got to be careful what you put into the function. You don't want to put something into the function that causes something bad to happen for an output. What would be bad? Something that is undefined. How would you get something like that? Well, if you had to divide by 0, your solution would be undefined. You can't have that. Or if you got a square root of a negative value, your radicand, the thing under the radical sign, was a negative. Taking the square root of a negative number gives you something that's imaginary. All right, so you don't want that. You don't want to put anything into the function that causes bad things to happen. Things that are undefined or things that give you a square root of a negative number. Here's a case here where if I substituted 1 for x, my function would give me back a value of -1/2. Notice here, if I put in 3 into this function, I get a 0 in my denominator. Therefore, this whole thing would be undefined. All right, since division by 0 is not defined, f of 3 does not exist, which means 3 is not in the domain. Here's a case where you got a function here. I'm not worried about the numerator. I can have a 0 in the numerator. I'm not worried about getting anything imaginary because I don't have a square root. What I'm concerned about is the denominator. That guy never equals 0. So what we do is we solve that denominator for 0, find out what values here, -3 and 1, would cause this denominator to become 0. So what I'm saying is that in the domain, you can't use -3, nor can you use 1 because it would cause this function to have a 0 in the denominator, meaning that the solution would be undefined. Can't have that. The domain consists of any number you want. Just don't use -3, nor can you use a +1. All right, we're asked to evaluate these three functions. F of 3, you can see what I'm doing here. In place of x, I'm substituting in 3, and then in place of x there, I'm substituting 3. And just doing the algebra, f of 3 comes out to be a -21. Here I'm finding f of x, which you know to be this guy right here. He gives it to you, plus f of 3. Well, f of 3 we just found out was -21. So I'm taking the function and I'm adding a -21. Adding a -21 is a -21. Here we're finding 3 times f of x. Well, there's my f of x, and I'm going to multiply it, distribute it 3 times both the terms inside. Doing so, I end up with -9x squared plus 6x, distributing it 3 times both the terms. Here we're asked to find f of -x, so wherever I see x in my function, I replace it here again in red with -x. Doing the algebra, -3x squared minus 2x, just do my multiplication here. Of course, I'm squaring the -x first, giving me a +x squared minus 3 times +x squared minus 3x squared. Minus the minus f of x. Well, there's my f of x. A minus sign preceding that changes the signs of both the terms within the parenthesis. A negative preceding this parenthesis is like multiplying through by a -1. Simply stated, it changes the signs of the two terms inside. F of 3x, wherever I see x in my function, I'm replacing it with 3x. I'm going to square it, multiply it times a -3. Doing the algebra, -27x squared plus 6x. Here we're asked to find f of x plus 3. Once again, I'll remind you that when you square x, this binomial, you have to FOIL it. X plus 3 times x plus 3 ends up with x squared plus 6x plus 9. FOILing. All right, x plus 3 times itself. Multiplying the result by a -3 and then combining like terms. This last one's a toughie. It's called a difference quotient. All right. We're finding f of x plus x minus f of x. In fact, we'll study this as a separate topic. It's just very lengthy. All right. So f plus x, you're going to substitute in place of x plus x. You're going to FOIL this out and double it. Then you're going to subtract f of x. Just very lengthy. I mean, FOILing and multiplying by minus 3, combining the like terms. And at the very end, I see in my numerator, the 3x squared and the minus 3x cancel out. These three terms all have an x common factor, factoring that out, and then finally canceling out the two x's. Very lengthy, but we'll study this as a separate topic. I'll talk about using your calculator to evaluate functions. All right, this is a screenshot of it. We'll talk about that in a separate video. We can also talk about another way of calculating the value of functions by using the vars menu. Here again, I'll do a separate video on that. All right, once again, the domain set of all, the domain is a set of functions inputs. The range is a set of the function outputs. Domain simply states your x values and your range, your y values. Here again, I'm plotting, graphing a square root function. My domain set of all inputs. As I go to the graph, nothing less than -4. -4 is good all the way out to infinity. All right, I can put any x value I want as long as it's -4 or larger. All right, your range is from a set of y values. Your smallest y value is 0. And this graph goes all the way up to infinity, from 0 to infinity. These are just a graph here, and I'm asking you several different questions. You can actually take a look at this. In fact, we go back to that one slide. All right, in fact, let me kind of just actually do this. F of 0 and f of 6. Well, f of 0, when x is 0, y is 0. When x is 6, your y value is 0. F of 2, when x is 2, your y value is -2. When f is -2, your y value is 1. All right, -2, 1. F of 3 is a positive or negative. Well, here's 3 right here. The graph is below the x-axis. Your y value would be less than 0. F of -1. Well, here's -1 right about here. All right, it's not labeled, but the graph is above the x-axis, so your y value would be positive. For what values is f of x 0? Well, when x is 0, y value is 0. The origin, 0, 0. For what values of x is f of x less than 0? Well, where is the curve below the x-axis? Between 0 and 4. All right, at 0, it's not less than 0, it's equal to. So it would be parentheses between 0 and 4, open parentheses on both sides. The domain goes from -4 to 6. From -4 to 6, your range goes from -2 all the way up to +3. What are the x-intercepts? 0, 0, and 4, 0. Or I can just say 0 and 4. What are the y-intercepts? Y-intercepts are 0, 0. The only place where it cuts across the y-axis. How often does the line y equal -1 intersect the graph? If I were to draw a line at y equals -1, it would cut across the graph there, and it would hit the graph there. If this is -2, -1 would be there, drawing a horizontal line. It would touch this graph in two spots. If I drew a line at x equal 1, it would cut the graph, it looks like, in 1, 2, 3 spots. All right, I have to draw a horizontal line at x equals 1. Cut the graph in 3 spots. For what value of x does f of x equal 3? When is my y value 3? When x is 5. All right. For what value of x does f of x equal -2? When x is +2, your f of x, your y value is -2. All right. I hope that helps. I hope.